So, as we know, as we remember, um, excitable cells, such as nerve cells and muscle cells that are excitable, able response to the action of the stimuli by the process of the excitation. Excitation, we discussed already, include two processes, two response processes. First of all is non-specific, is action potential or electrical excitation of excitable membrane. And second one is specific reaction of this type of cell. Depending on the structure, depending on the character of activity, it will be different. For example, muscular cell will contract. Action potential, actually, action potential is the activator of the following reaction of the tissue. So, and on this part of the lecture, we discuss what is it, action potential, what properties has, and what is time course of the processes that I include in this. Okay, so action potential, we know different names of this that are actually synonymous. We know action potentials like spikes, spike, or sometimes we can call it like electrical impulse or nervous impulse. Actually, that are the same. Okay, so we start define it. What is action potential? Physiological definition of the action potential looks like this. An action potential is a rapid, very rapid, very often it spreads only 3-4 milliseconds, is a rapid short-term change in membrane potential that include rapid depolarization followed by rapid repolarization of the membrane potential of excitable cell, accompanied by a change in a sign of membrane charge. What does it mean? It means charge on the resting membrane become reverse. In resting period, we remember that external surface of cell membrane charged positively, internal negatively. In peak of excitation, this charge become reversed, like this. Okay, so then this phase calls specifically like overshoot or reversion. Okay, so on the picture on your screen, you may see simplest variant of this action potential, a classical shape, for example, for nervous cell or muscular cell, skeletal muscle cell. Some specific moments we can see for the myocardium cell, for contractile, for pacemaker cell, with specific moments for smooth muscle cells, but usually this classical shape that durated relatively 4-5 milliseconds. On this picture, these 4 will be. Okay, so what are the phases I include? First of all, we need to remember about the presence of resting membrane potential for any excitable cell. When we not act by the stimulation, cell using energy of ATP by the active transport create gradients of the ions, for sodium, for K+, for chlorine ions, and these gradients will make resting membrane potential. In most of the variants of the cells, we can see average value like -70 millivolts. Okay, so when we apply stimulation, this phase on graph, we can call like resting membrane potential, maintaining of resting membrane potential. Second phase, when we apply the stimuli to the membrane, stimulus should be threshold or supra-threshold on membrane will changes ionic permeability. Stimuli act to the ion channels of membrane. What are they? It is sodium ion channels. We can call this like slow sodium ion channels. It may be different sensitivity of this. For example, some cells react to the presence of some chemical substance in extracellular space, extracellular fluid, such as neurotransmitters, such as some hormones or another types of the ligands that interact with the receptors of ion channels, open it, and ions, sodium ions, start to move down on concentration gradient. In our case, sodium moves inside the cell. Movement of the positive charged ions, like sodium, will make decreasing of membrane potential. These changes of membrane potential we will call like depolarization. So this phase we can call like slow depolarization. Depolarization, decreasing of membrane potential difference. Slow depolarization explains by the inward sodium current. Inward sodium current. Okay. So it may be different variants, not only ligand, maybe mechanical gating, maybe thermal gating, and so on. Okay, so this primary current, we can call this phase like pre-potential. Pre-potential. It is not action potential yet, but this depolarization is starting moment. If this level of depolarization achieves the threshold level, in our graph, this level equal to -50 millivolts. If this depolarization achieves this level, -50, we'll start generation of action potential. Threshold level achievement is a signal for cell membrane ion channels for the rapid opening of the voltage-gated sodium ion channels. And third phase on our graph is the rapid depolarization. Rapid depolarization explains by the opening of sodium ion currents. Sodium ion current, very powerful inward current, explains by the voltage-gated ion channels opening. Voltage-gated sodium ion channels opens. Okay, so in this type of ion channels, we can find voltage-sensitive elements that's sensitive to level of membrane potential. In this case, This level is minus 50. Okay, this very powerful inward current of sodium will very rapid depolarize cell membrane. In this point, depolarization achieves 0 level. That means membrane potential on this point is absent, absolutely absent, equal to 0. But changes of membrane potential not stops on this moment and continue to change. Following changes looks like reversion of membrane potential from this point and up, and we go up to the graph. Sign of the charge on membrane reversed. On this moment, charge outside the cell is negative, inside is positive. And this phase number 4, we call like overshoot or reversion of membrane potential. Opening of sodium ion channels will change membrane potential and make it close to equilibrium potential for sodium ions. That's why membrane potential become positive. After very rapid opening of membrane sodium voltage-gated sodium ion channels, these ion channels usually very rapid closes. On the peak of action potential, sodium ion channels very rapid closes. And it is not just closing of sodium ion channels. It is process of inactivation of sodium ion channels. In this state, sodium ion channel non-sensitive to the new stimulation. Stimulation for this, it is achievement of minus 50 millivolts. Till the recovery of membrane potential, these sodium ion channels will be in inactive state, and we cannot open it again by the repetitive stimulation. And a cell, excitable cell, become non-excitable because this state is refractory period. In refractory period, we cannot excite cell once again. Next phase of the process is the recovery of membrane potential, and we can call it like repolarization. Fifth phase, repolarization, that explains by the outward current of the K+ ions. As we can see, rapid sodium ion channels closes, and after that immediately opens K+ ion channels. Because these ion channels react slowly to the stimulation. It slow opens and take part in recovery of membrane potential. Outward current of K+ will repolarize membrane potential and make it close to the resting level, outward K+. So rapid repolarization followed by the slow repolarization, sixth phase. Slow repolarization explains by the gradually decreasing of K+ current when membrane potential comes down to the RMP, slow repolarization, and final phase is hyperpolarization. Hyperpolarization. So it is variant of the after potential. After potential. And ionic mechanism is decreasing of permeability for chlorine ions. Chlorine is negative charged ion, moves inside the cell and make polarity of membrane greater. So relatively resting level, that's why it is hyperpolarization. Cell become more polarized than in resting period. Another variance of after potential is depolarizative. Sometimes it is depolarization and then hyperpolarization. So these 7 phases are included in action potential. So what are the properties has action potential? Properties of the action potential. First of all is the ability to self-propagation along the excitable membrane. This self-propagation explains by the changing of the sign of the membrane charge in moment of action potential. When membrane potential become reversed, this local area of membrane can generate local currents. Local currents oriented along the membrane and will make movement of the ions along the same surface of membrane. This movement of the ions from excitable area and non-excitable area will produce shifting of membrane potential of adjustment areas, of the neighbor areas, till the threshold level. After achievement of threshold level, these areas will generate action potential too. And process like chain will transfer to the all excitable membrane. Finally, we receive excitation of all membrane, of whole cell, but primary it was local process. So we can conclude that action potential can propagate, but this propagation usually limited by the one cell. For the transfer into another cells, we need specific structure with name synapse. We will discuss it later. Okay, next property of action potential is the stereotypical shape and size. Shape and amplitude for particular tissue, for particular variant of excitable cell are similar. If we try to generate repetitive processes in the same cell, like myocardium cell, like muscular cell, smooth or striated, or neuron, we receive always same action potentials that are specific for neuron, specific for muscular cell, and so on. Okay, so next one, third phase, third property. Amplitude of action potential does not depend upon stimulus. Just enough to achieve the threshold level, and as following process, we receive stereotypical action potential. We cannot make action potential greater, more powerful as a response to powerful stimuli. So to the threshold and supra-threshold stimulation, cell will respond by the stereotypical answer to the stereotypical response. Okay. So last one, fourth property is ability of action potential, absence of ability of action potential to the summation. If we make stimulation, rhythmical stimulation to the excitable cell, and second stimuli of following will apply it in moment of the refractory period of previous. If action potential not yet disappear, we receive silence. We receive silence. Да-да.